We're going to go over how to run hypothesis test for two sample z-test of proportions. This means we have two different proportions and we want to compare them against each other. So instead of having only one sample as we did before, this time we're going to have two. So if we look at this example, it tells us a researcher wants us to determine whether medication is more effective than a placebo in breaking a fever within an hour. Out of the 450 randomly selected participants with a mild fever that were given a placebo, 110 found their fever break within the hour. So that's one sample. And now if we look at this, we have a whole nother sample. So whenever you have two samples, you have to use the apps that have the 2 with them. And this one's proportions, so we're going to use the compare two population proportions. If these were averages, you would use the compare to means instead. So we have the first sample. Now the second sample is out of 423 randomly selected participants with a mild fever that were given the medication. 128 found their fever break within the hour. Is there evidence to support the claim that the medication is more effective than the placebo in breaking fevers within an hour? And then we're also going to make a confidence interval. So for our null, we have that this time we have two samples. So we could call our first one P1. I'm going to call my second one P2. So instead of being equal to a number, this time we're having our first sample equal to our second sample. And then for the second one, we're going to say P1 is we want more effective than P2. Now what's going to be really important here is that you need to make sure you are writing down what your P1 is and what your P2 is. So P1 here, we said that the P1 is greater than P2, which means the medication is more effective than the placebo. So P1 we're calling the medication, and P2 is our placebo. So make sure you define which is which, because you want to make sure we're putting the right numbers with the right ones. So the medication greater than the placebo. So the medication we had, the medication is this one. So out of 423, 128 were given the medication. So medication has n equals 423, and it has our number of successes is 128. And I like to write these down so I don't get them confused when I'm putting them into the app. So the placebo, we had 450 total, and 110 had their fever break. All right, so now that we have all our numbers, the next part is to check the conditions. I'm not going to check them, but if you looked, so you would do N1 times our probability. So if you think about it, we have about 450. Chance that this happens about 1/4. 1/4 times 450 is going to be higher than 10. So we'll be good with those. The two samples are independent. Yes, different people were given the placebo, different people were given the medication. They don't impact each other at all, so they're random. And we're going to assume that they gave the population that would have fevers would obviously be more than 4,000 people. So conditions we're good with. So the next part, we need to calculate our test statistic and our p-value. So we're going to go into the app. Again, whenever you're just given these numbers, that means we're going to do, we have our numbers of successes. So it told us the number of successes, so we're going to do that one. So for our group 1, we have that the n was 423. And then we have our number of successes was 128. And then for the sample size for group 2, we had 450 people. And the number of successes was 110. And then we need to put into our significance test. And also it's helpful to name the groups. So group 1, again, we said was our medication group. And group 2, we said was the placebo group. And then you want to make sure that these line up with your problem. So again, medication, we had 423, 128. For the placebo group, we had 110 and 450. So those are good. You see our sample proportions. We get our test statistic. And we need to make sure that we choose our alternative we said was greater than. So we want to make sure these line up. We have equals 0, greater than 0. You see this looks a little bit different. All they're doing is subtracting this P2 to the other side. So if you subtract it, it'll be P1 minus P2 equals 0. That's all they're doing. And then now that we have our greater than, we get our test statistic is 1.93. Our p-value is 0.0269. And we are comparing this against the alpha level of 0.05. That's our alpha. 0.0269 is less than 0.05, so we reject the null. Remember, p less than alpha, reject the null. Null is, p is low, the null's got to go. So whenever we reject the null, we are rejecting that they're equal. We're saying no, they're not equal. We're saying there's evidence for the alternative. So that means there is convincing evidence that the proportion of people who had their fever break with the medication, because remember the P1 is the medication, so the proportion of people who found their fever break with the medication was higher than those without the medication. So we can say that there is evidence that the medication is more effective than the placebo in breaking fevers within an hour. So we do have evidence for the claim in this case. And that is how you do a 2-sample z-test for proportions using the app.